Hello everyone. In this video, we will do some examples using the recursive formulas. For a select and ultimate mortality model with a 1-year select period, you are given that the 1-year survival probability for a select life, that is P bracket X, equals 1 plus K times the 1-year survival probability for non-select life Px. And then A double dot, and then for select life X colon angle N is 8.0063. The corresponding present value for non-select life is 7.9555. Calculate the value of K. Let's take a look at the solution. We are given the actual present value for the select life, the n-year term annuity due. And here we will make use of the relationship to get the actual present value for the n-1 year annuity due at age x plus 1, bracket x, the select age x, 1 year later. And we can make use of this recursive formula. And because this is a 1-year select period, so the corresponding angle x plus 1 is simply the standard life x plus 1. And from this, we can relate back to A double dot x angle N using the relationship here. And therefore, we will start with this recursive formula. Here we replace the angle x plus 1, the age angle x plus 1, simply by x plus 1. All right, we are given the expression for the 1-year survival probability at select age x, which is 1 plus k and then times px. And then the next step, the last term here, we have the expression nu times px and then times this A double dot. This can be expressed as 1 plus the bracket 1 plus k and then A double dot x colon angle N minus 1. And then we can do the substitution. With the bracket x, the A double dot is 8.0063. For standard life, 7.9555. From this, we can solve for the value of k. We have 0.0073. Another example. Again, a select and ultimate mortality model. And here we have a 2-year select period. Given the mortality table, and then for standard life, A double dot 41, colon angle N is 20. We want to calculate the corresponding A double dot at select age 40 and then plus 1. Link up the two quantities here. Using the recursive formula, with select age 40 plus 1, and we get this recursive formula. And then because this is the model with 2-year select period, at age 42, this already corresponds to the ultimate table. So we can leave out the bracket. Bracket 40 plus 2 is simply age 42. And then for the standard life, A double dot 41 colon angle N, we have this recursive formula. And then we can start to do the substitution. All right, so we have 20 for this notation. And then P41. P41, the ultimate probability. Q41 is 0.11, so P41 is 1 minus that. We have 0.89. We don't know the value for nu because we don't have the interest rate. It doesn't matter. We can still solve for A double dot 42 angle N plus 1. So this gives us an expression in terms of nu. Plug this to the second relationship, and you can see that the nu can be cancelled. And we can get the answer, 20.427. The next example. For a 15-year certain and life annuity immediate, we are given that the corresponding actuarial present value is 20. The mortality probability, QX, is 0.03. The interest rate is 10%. If the value of PX is decreased by 0.02, calculate the revised value for this annuity. All right. Only the survival probability or the mortality probability at age X is changed. And therefore, we can make use of the recursive formula to accommodate the change. Here we have the N-year certain and life annuity immediate. We get the expression on the right-hand side. PX is changed, so we only need to change the value for QX and PX accordingly. Okay, the annuity certain does not depend on PX. And then the N-1 certain and life annuity immediate at age X plus 1 similarly does not depend on PX. So we can make use of this relationship to get the revised value. All right, plug in the value for N. N is 15. And then substitute the numbers. The 15-year certain and life annuity immediate, the left-hand side here, the expected value is 20. And then nu is 1 over 1 plus I is 0.1. And then we have the 14-year annuity certain. So A angle 14 is given by this expression. QX is 0.03, and the corresponding value for PX is 0.97. From this expression, we can get the value for the 14-year certain and life annuity immediate, which is 21.4216. And then the revised value. PX is decreased by 0.02. The original PX is 0.97, decreased by 0.02. So the new PX is 0.95. So we change the value for QX. The revised value for QX is 0.05. And then plug in the revised value for PX, which is 0.95. We have the value for A angle 14. And we have calculated the 14-year certain and life annuity immediate here. And upon calculation, we get the revised value, 19.7445. And this completes the problem. All right, that's it for today's video. Thank you for watching and see you in the next video.